Hey, let's talk about comparing two sales persons. All right. And again, playing around with my fun new tools. So I've got Bob and I've got Larry. All right. And we've got sales numbers, right, for all of them. And basically, we just begin to plot each sale that Bob makes. And a pattern would begin to form over time, and if the patterns sort of look like that, then we would argue that Bob has a nice bell-shaped curve. The average indicates the amount of sales that Bob most often will get, and then of course you got a little outlier out here in the tail. You got these are very rare, right? These are probability distributions, so Bob is most probably going to sell in this range. And then we're plotting Larry's sales, and I'm just going to make this up for the example. It's sometimes the danger that, or the mistake that companies make comparing people. Here we've got Larry's sales, but Larry does not have a normal distribution, simply meaning it does not look like a pretty bell-shaped curve. So here's Larry's average sales way over here, and the reason it's over there, now remember, average is supposed to reflect what is most often going to happen. So if you calculate the average of your class at college is 24 years old, then you're telling me I am most likely to meet a 24-year-old. So in this example, let's say that Larry's average sales is 50 and Bob's average sales are 50. So Bob and Larry both are equally rewarded as salesperson. Although actually, unfortunately, in sales, look at Larry. He's got a couple really good hot sales out here at, let's say, 300, and Bob's biggest was 150. Larry gets the reward. That also then might explain, by the way, I meant to say that Larry has an 80. Okay, so Larry is looking good here on the sales vice president scorecard because all he or she sees is a 300 top sale and Larry having an average of 80. And that is not as good as Bob, who's a 150, as we say in Atlanta, whose average is 50. Now, what's the mistake here? Well, first off, best sale and best sale is a single data point, so there's no error in comparing 300 to 150. But the mistake we made here is we compared 80 to 50 when we have a non-normal distribution. So that's an example where we need to use the median. So when the data is not normal, we need to compare the median. Now, in a truly normal distribution, the mean and the median would be the same. So just for the sake of the argument, I'm going to say that Larry's median, which is, again, this is a better representation of what he most often sells. Oh, a little update there from my computer that ruined everything. And this is an example of what Bob most often sells. So most often, Bob is actually better than Larry. Now, why did Larry have a higher average? Because he had an outlier. Average is a mathematical formula. Add everything up, divide it by the total. So you have to be very careful in corporate America comparing averages, especially on something as important as sales. You have to check normality, non-normal, normal, and this is something that most people don't do because most people aren't even looking at the shapes and distributions of data. They're simply looking at raw numbers. So here's Larry. He's getting the big reward, where Bob might actually be your best salesperson overall. All right, so what are some statistical ways to look at Bob? Well, and Larry, I'm sorry. So we have a continuous Y, and that is sales, right? Sales is in dollars, and it looks like any number is possible. And we have a discrete X, right? Bob or Larry. It is either or. So this would be binary if you want to go a little bit further into what type. So we simply check out what's the test we can do for here, and it's the 2 sample T. And if you want to compare medians, it is the Mann-Whitney. right? The man Whitney. So that is for medians, and this is for average. So I ran the average test over here, and we've got two options. I'm still trying to figure out how to get this mouse to come over faster. We have mini tab, okay, here. And then, like I said, I've been playing with this free software, Jamovi. One thing I'm having trouble with is inserting data. You basically have to take your Excel spreadsheet and turn it into a comma delineated format. I don't like that extra step, but we're getting the same. Now in this example, we've got Bob's sales, Larry's sales, and you can see here that Larry is clearly not only a better salesperson, but more consistent. Consistent would be the length of this area. So Bob has a lot more variation than Larry. And then we come down here, our p-value is less than 0.05. So we can assume the null hypothesis is, let's go over here and write that. HO, the null is that we are equal, and HA is that we are not. Now you can also do greater than and less than. Over here in Minitab, I love Minitab. It goes a step further. It actually tells you the answer. So when people ask why would you use Minitab, for that reason right there. This is the Porsche of hypothesis testing for the non-statistician. So Bob averages 287 in this example. Larry is 400. And you can see the graphical difference. Here is the 95% confidence interval for Bob's sales and his average. And look how tight the spread is here for Larry, 95% confidence that his average falls somewhere in this range. And there is his actual average. And I think that's all I did. So there you go, just a fun way to compare two things. In this example, it was salespeople, but you could compare two departments. You could compare two district managers. You could compare two, police departments on something. Just whatever. All right. Now, if you have three or more, then it's going to be the ANOVA, which we will discuss later. All right. So a quick go back. One more example here real quick. We can add the box plot to this, and that would look like this. Okay, so Bob. Box plots are simply histograms drawn on their side, so I'm going to go ahead and draw it on the side. You typically, that's a new word, see them like this. So there's Bob at 50. There's his best sale at 150. Let's say his lowest is 15. Then I'm going to use this data that we came up with. Larry's center is here at 45. All right, the line in the middle of the box plot is the median. All right, the median. And let's say that Larry has the same lowest sale. All right. But Larry has a lot more variation, right? So you can see that. If you have sort of this weird, not even box plot, it reflects those same distributions, okay? So there you go, how to compare two things when your y is continuous and your x is discrete. Best of luck to you out there.